Hello, viewers. This is the second lecture on the Internet of Things. We are discussing the topic wireless sensor networks. In the last lecture, we have seen the basic construction of the sensor node, the various parts which are present in the sensor node and their functionalities. And also, we have seen the different mode of detection by which the sensor node detects the different objects. So, today, in the second lecture, we will discuss about the various challenges involved in the field of wireless sensor networks. So, the first and foremost challenge is the energy efficiency. We have seen in the construction of the sensor node that the sensor nodes are powered by the batteries because they are not able to given the power supply from the mainstream or grid because they are the normally located in the remote places where people do not reach normally, and therefore they require to be supplied by the battery. Okay, and in these cases the lifetime of the particular sensor node mainly dependent on the battery life. So therefore the energy efficiency is a very much concerning fact about the design of the wireless sensor networks. So power consumption is required for the different things like the functional sensing, communication, data processing. Okay, for this kind of purpose the different uh, power consumption is there. So therefore the sensor lifetime is normally dependent on the battery power. Okay, so therefore the power efficiency, energy efficiency is very much required for the sensor nodes. Next one is the limited bandwidth. So basically the sensor node senses a large amount of data, and this data need to be transmitted to the mm, cluster head or the other nodes, and therefore the transmission requires a wireless medium, and normally the transmission rate is limited to 10 to 100 kilobits per second because the limitation of the availability of the bandwidth. Okay, so bandwidth limitation directly affects the message exchange among the sensors, and the message exchange among the sensor is required to maintain the synchronization between the different nodes. So therefore, uh, while designing the sensor node, the amount of data that required to be sent, that is also very much important. Next is the node cost. So basically, the overall costing of the sensor network is dependent upon the cost of the single sensor nodes or individual sensor nodes. If the individual sensor nodes costing increases, the overall financial metric of the WSN system is also increases, and therefore uh, the acceptancy of that particular type of sensor network is also less. So therefore, depending on the application of number of sensor nodes to be scattered randomly on the overall the environment, such as weather monitoring or pollution monitoring, this kind of system, uh, the overall cost of the WSN is appropriate. It will be more acceptable and useful for the users. Next is the deployment. So the sensor nodes are need to be deployed in a particular area of concern where we are going to monitor the particular event like the weather monitoring or pollution monitoring, these kind of things. So therefore managing and deploying the sensor node in a particular area, that requires a efficient planning, so that using limited number of sensor node, maximum area can be covered. So there are basically two deployment model present. One is the static deployment model and the another one is the dynamic deployment model. In case of the dynamic deployment model, the sensor nodes are randomly put in different places of the area of concern, and then depending on their performance, the optimization of the location is done. And in that case, the sensor nodes can be moved from one place to another place depending on the requirement. So therefore, it is called the dynamic deployment. In the other scheme, that is the static deployment, it chooses the best location according to the optimization strategy. And the location is not changed in the lifetime of the WSN. So next one is the design constant. The primary goal of wireless sensor design is to create smaller, cheaper, and more efficient devices. So it required to be small and portable because the nodes need to be deployed in the different areas where the different parameters we are going to measure, and obviously they need to be cheaper, as we have already discussed. uh, so there are other different type of requirements also, like the energy efficiency, or optimization of the various number of parameter that can be measured using a particular sensor node. Okay, so depending on different aspect, the sensors nodes should be designed, and according to that, the overall WSN system will be modeled. So another important factor or important challenge is that is the security, because in case of the WSN, we require to communicate with the different sensor nodes. Those are basically present at the remote locations, and in those remote locations, normally the locations are unattended and insecure. So in such location, there may be some intruders that can make some that can create some harmful programming in such sensor nodes, and so that the sensor node will send some false routing data that can be harmful for throughout the integrity of the overall wireless sensor networks. So therefore, ensuring the proper security is another big challenge in the field of wireless sensor networks. So these are the various challenges that we have talked about. Now let us come to another aspect of the WSN, that is the sensor web. So sensor web is basically a vast field of the sensor web. Sensor web is basically a an application of the wireless sensor networks, where the sensor networks are directly communicating with the World Wide Web. So basically, it is here in this particular diagram, the architecture of a particular sensor web system is shown, where the sensor node, this part is showing the physical sensor node which is present in the environment, and that is useful for the maybe the weather forecasting or the pollution detection of a particular area. Now the sensors which are measuring the different parameters from the environment, that is required to be uh, used by the different category of people, like the researchers, by the some collaborators, or some other any other type of instrumentation systems which requires these sensors data for further processing and maybe prediction of something like that. So therefore this data need to be uh, associated in the World Wide Web, so that the data can be accessed from any part of the world by the different clients. So for that, the sensor web is basically required. So here, what happens in this case, we can see that the sensor which are deployed in the environment, that are generating the data, and that data is basically present in the websites, in the various websites, and from that website the different researcher collaborator can access the data, or maybe some other software model that can also collect the data from the sensor web. And also there is a computer grid which can also access the data, and from that particular data, using the cloud computing, some other derived data set can be also generated. So in this way, sensor web is a particular uh, uh, it is basically a combination of the object or service oriented programming and the sensor wireless sensor networks. Okay, now for the enablement of the sensor web, there was a certain rule set that was a standard rule set which was developed by the Open Geospatial Consortium. This rule set is called the sensor web enablement. Now, this sensor web enablement you specifies the particular rule set for interfaces, protocols, and encoding that enable discovering, accessing, and obtaining sensor data, as well as sensor processing services. The figure shows a typical collaboration within the sensor web enablement framework. So here we can see that in this particular framework, there are the real world sensors which are deployed in the environment. Now, these sensors are measuring the various parameters. So, they are basically generating some data, or they are basically getting some observation, generating some, making some observations. So, these measurement and observations are required to be stored in the cloud environment. And for that, it is done using a standard language which is called O and M, or sensor model language. Okay. So the data is encoded in form of observation and measurement, or sensor model language. Now, the data which is stored in the cloud environment that required to be accessed by the client. So we need to incorporate some security so that the client is some having some authentication, and that thing is normally done by the registry. So in the registry, this system have the ability to make the registration of the client, and when the particular client searches for some sort of data generated by the sensor, that authentication is checked by this registry. And in the registry, there is also the list of the type of data which are available, so the client can search available services, that what type of service that can be achieved from this particular sensor web. So according to that, the client can search, and then he can plan that what type of data he want to access. So so this planning of the data request is sent to the SPS, that is the sensor planning service. So the amount of data which is required by, or the type of data which is required by the client, that is request is given to the sensor planning service. Okay, now this sensor planning service sends the request to the sensor collection service. So the sensor collection service has basically the storage of the this O and M sensor ML form, storage of the data in this form. So from here, the sensor collection service gives the request to the particular sensor network, where the that is basically in the physical environment. And according to the request of the client, the proper parameters are being sensed from the environment, and that is being stored in the sensor collection service. And when this overall database which is requested by the client have been generated, the sensor collection service maintains that particular data set, and through the WNS, that is the web notification service, the notification is sent to the client that the requested dataset has been generated. And depending on that notification, the client now can access the particular dataset from the sensor collection service. So this is the overall workflow of the particular sensor web. So this is how the wireless sensor network can be helpful to generate the particular type of data according to the requirement of the client, and the client can access data from the sensor web, where the client has no client doesn't have to understand or know that where the sensor is actually established or how the sensors are functioning, all those complexities. So the client can easily access the data, and then they can use it for the further processing or some other research. Okay, so this is the how the sensor web can be helpful for the different research and different technical aspects applications. So next comes the another important fact about the WSN is the cooperation, because in the very first day we have seen that the wireless sensor network basically communicate using a multi-hop path. So multi-hop path means what? A remote sensor node communicate to the cluster head or the main server using the other sensor nodes which is present in between the main sensor node and the remote sensor node. So the in such situation, the intermediate sensor nodes require to be act as relay which accept the data which is coming from the far away sensor nodes, and that is required to be transmitted to the next nearby sensor node to the server. So therefore, the sensor node should be cooperative in nature so that the data can be transmitted from the remote node to the server. But in this case, we all know that the energy efficiency is also another important aspect for the sensor node. So the maximum energy required by the sensor node is during the transmission of the data. And if the sensor node go on transmitting all the data which it receives from the another sensor node, then its power will be there will be a large power consumption in that particular node, and therefore the sensor node's lifetime will be reduced. So therefore the sensor node has to be selective that which data it will send and which data it will not send. So depending on that, the cooperation is also decided. That therefore the two extreme cases can be possible over here in terms of the cooperation. That is, the node may or may not cooperate in the communication of the data. So there are two extreme cases. One is the total cooperation and another one is the total non-cooperation. In case of the total cooperation, all relay requests from the successor node are accepted and data is being transmitted to the next node. Whereas in the total non-cooperation, no relay requests are accepted from the successor node. In such scenario, the network throughput will rapidly go down. So depending on the situation, that whether the node is cooperative or not, there are some classification of the sensor node. Okay, so here is the classification, that is the behavior of nodes in WSN. So the WSN nodes may behave in two ways, that is the normal behavior and another is the misbehavior. In case of the what is the normal behavior means the nodes are sensing the different parameters from the environment, and they are sending their own information to the next node, as well as they are sending the information which they received from the another further nodes. So this is the normal behavior. Now, what is the misbehavior? Misbehavior can be of two types basically. One is the unintentionally and another is the intentionally. In case of the unintentionally, there may be also two cases, that is the failed and badly failed. Whereas in case of the intentionally, there are two cases, that is the malicious and the selfish. What is the unintentional behavior? The unintentional is basically two types, that is the failed node. So here the failed nodes are simply those that are unable to perform an operation. This could be because of power failure or some environmental events. And what is the badly failed node? Badly failed node exhibit the features of failed node, that is they cannot generate the data or they cannot transmit the data. Along with that, they can send some false routing messages which can be a threat for the integrity of the network. Next is the selfish node. So selfish node are basically non-cooperative node. They are uh, their unwillingness to cooperate as the protocol requires. Means as the protocol is a multi-hop protocol, so in that case, the unwillingness of cooperation will basically break the network. Will basically break the flow of the data from one node to the other. Whenever there is a personal cost involvement, here the cost represent the cost of the energy basically. So as the transmission of the data requires large amount of energy, so in that cases some nodes may behave like the selfish node, that they were not willing to relay the data from the previous node to the next node. So the packet dropping is the main attack by the selfish nodes. Next is the malicious node, aim to deliberately disrupt the correct operation of the routing protocol, denying network service if possible. So in that cases, some malicious program or some harmful program may be incorporated in the remote location nodes, and that generates some false data or some wrong data, which can break the integrity of the WSN. So the misbehavior of the node can be two type, basically the temporary misbehavior or the permanent misbehavior. In case of the temporary misbehavior, the nodes are called the dump node. And in case the dump node is basically generated maybe due to some environmental failure, bad weather condition like the heavy rainfall, fog, this kind of condition. So in such scenario, if the environmental condition improves, later the data which is generated by this particular sensor node, that can be sent to the server side. But that is a temporary misbehavior. There are basically two scheme, means when the particular dump behavior is shown by a particular sensor node, so in that case to uh, um, continue the operation of the WSN, it is required to re-establish the connectivity between the dump node and the other nodes. So there are basically two ways to re-establish this connectivity. That is the connectivity re-establishment in presence of dump node. That is the when in this case, the when the dump node is not communicating, they are basically storing the data in their own memory, and then when the condition improved, the dump node will send that data to the next node. And what is the connectivity re-establishment among the sensor node with adjustable communication range? So in this case, the sensor node which is behaving the dump, that is avoided, and the previous node which is properly functioning, that node's communication range is increased so that it can communicate to the next sensor node, and the data can be transmitted to a more means the to the farthest location where the next sensor node is present. So in this way, avoiding the dump node, the communication can be established in the overall wireless sensor networks. So this is the as per the behavior, there are the different classifications of the sensor nodes. So that's all for this particular discussion. We have collected, this is the references from where we have collected the information that is discussed in this particular slide. So thank you. uh, let's end it over here.